All right, this is a quick video just to go over the review activity that we did in class, the last in-person class before our Chapter 8 quiz. So just in case you were absent or something, I wanted to make this video available to you as well. For those of you who are in class, we talked about this already, but I gave you a word problem, and it's about my son Levi, who's 3 years old and has a habit of sneaking into my bed. So we need to draw a triangle ABC, right there, and plot all 3 points, connect the dots, you'll have some kind of triangle. I'll show a more detailed answer key in just a moment. That's all you need to do for number 1. For number 2, we're going to draw a second triangle A prime, B prime, C prime, and this triangle is going to be the result of reflecting the triangle from number 1 over the line x equals -5. So find -5 on the x-axis. If it's x equals a number, remember that's going to be a completely vertical line, and we'll take the first triangle and reflect it over to get the next triangle. Finally, my son rotated this time on the bed, so you're going to rotate triangle A prime, B prime, C prime, not the original ABC, but whatever we graph here in number 2, we're going to take that second triangle we draw and rotate it 90 degrees clockwise about the origin. So we'll take a triangle, rotate it around the origin 90 degrees, and we'll have some new triangle there. All right. Lastly, I asked you all to fill in the blanks. It's a good idea to not just rely on the graph and draw your triangles. Write out the ordered pairs. Should be a comma there. So there's our answer key. These 3 points, A, B, and C, were given. You just need to plot them and connect the dots. That's where Levi fell asleep at midnight when he climbed into the bed. At 2 a.m., we reflected the triangle over the line x equals 5, or I'm sorry, x equals -5. A common mistake I saw in class was that some people had A prime here. This is not a mistake. This should be B prime. The thing is, in this pre-image, A is on the upper left corner and B is in the upper right corner of the triangle. If you have A prime here and B prime here, then you did not reflect. You get the same, a similar looking triangle. It's exactly the same points, just in a different order, and the order matters. If A prime is here, then you actually translated. This is a slide. You took the pre-image triangle and translated it to the left 6 units. But that's not what I asked you to do. We need to reflect it over the line. So in a reflection, if A is 2 units away from the line of reflection, A prime needs to also be 2 units from the line of reflection. Similarly, if B is 4 units from the line of reflection, then B prime must also be 4 units away from the line of reflection. Hopefully that answers number 2. After that, we need to rotate. In number 3, we were asked to take triangle A prime, B prime, C prime, and rotate it 90 degrees clockwise. You should definitely have your rotations and reflections and all that in a note card. That we had rules for them, at least for special ones. So we had rules for rotating 90 degrees, 180 degrees, rotating 270 degrees, and rotating 360 degrees. That's a bad 8 here. There we go. Now keep in mind, in our notes, all of these measures, angle measures, are measured counterclockwise. However, this problem is asking us to rotate clockwise. So you need to remember that taking a triangle and rotating it 270 degrees counterclockwise will put you in the same spot as rotating 90 degrees clockwise. Since we've been asked to rotate 90 degrees clockwise, we're actually going to use the 270 degree counterclockwise rotation that we have in our notes, which says that XY should go to y negative x. Let me just double check. I think that's right. Yeah, y negative x. So for point A prime, which is at negative 7 comma 4, I got that from right here. We're going to apply our rule. So if xy goes to y negative x, negative 7 is our x, so the opposite of x, negative x, is actually going to be the opposite of negative 7, which is positive 7. And then y is 4, so we're going to put 4 right there, and that's how we get the coordinates for A double prime. This should be A double prime. Do the same thing for B prime and C prime. You'll get these points if you do it correctly. There we go. And that's it for the first exercise, for the front part of the page. On the back, I did not make an answer key yet, but we'll just go through it right now. So I give you two quadrilaterals. Quadrilateral RAFT is the pre-image, and when we dilate it by, it's not a given scale factor. We have to find the scale factor, but when we dilate it, we get R prime, A prime, F prime, T prime. Now, it doesn't tell us that it's dilated about the origin. In fact, it's not. We have to find not only the scale factor, but also the center of dilation. So this one's a little bit more challenging because none of these sides, R to A or A to F or F to T or T to R, none of them are completely horizontal or completely vertical. So we can't just, if it was completely vertical, we could just count, okay, this is however many units long, right? Instead, we need to come up with another way to find corresponding lengths. I'm going to use, blue. And you can pick any corresponding sides you want. I'm just going to pick T and F. They seem most convenient to me, but you might have picked different sides, and that's okay. Since the line segment TF is not completely horizontal or completely vertical, we could draw a slope triangle. So to get from T to F, I have to go up 1 and over 7. And then we'll draw the corresponding slope triangle in the image. To get from T prime to F prime, I have to go up 2 and over 14. Remember, to find the scale factor, we're going to pick any image length we want and divide it by the corresponding or the matching pre-image length. I'm going to pick these for the sake of example. So 14 would be an image length, and 7 would be the matching or the corresponding pre-image length, and 14/7 reduces to 2 over 1, which is just 2. Our scale factor is 2. You could have picked a different length. You could have said 2 over 1, and that would have worked just as well. You could have also used a different measure. Maybe you measured from R to T, or it doesn't matter. As long as you count up the units correctly, you should still get a scale factor of 2. I erased those blue marks because I want to show you how to find the center of dilation. We have a rule for dilation centered at the origin, where you just multiply x and y by the same number. But if it's not centered at the origin, we need to rely on the fact that corresponding points like A and A prime, they will always be collinear or on the same line as the center of dilation. So if I look at the line through A and A prime, the center of dilation has to be somewhere on this green dotted line. Now, it might be somewhere in the shape. Keep in mind, you might have to extend that line out. Maybe the center of dilation is somewhere over here. I don't know yet. But what I can do, A and A prime are not unique. The center of dilation is collinear with any two corresponding points, like F and F prime. The line through F and F prime is also collinear with the center of dilation. So is T and T prime, or R and R prime. And we should be able to see the only point that's on all of these green dotted lines. It's this, I'll use pink, I guess, right here, this point right here. The coordinates of that point are -3, 2. And that's the center of dilation. All right, come to class prepared because we're taking a quiz for Chapter 8 next time I see you. Make sure you have your note card ready with all your rules for dilations and rotations, reflections, translations. You should know how to find a scale factor. You should know how to find the center of dilation. See you all in class.